Okay, good evening. All students here, all from 5 students. Once again, see you all again here. Okay, today is Monday, so this must be the Monday from 5 groups. Okay. So, how was your day? The whole morning, your school lesson, okay or not, everyone? Kevin Lim, how's your school lesson today? Kevin? Okay or not? Kylie Wong, what about your lesson in school this morning? Okay or not?
Yeah, okay, sir.
Enjoyed it, Okay, come. Can someone please check for me your paper? This your last lesson. This Pascal principle. Have we finished up everything? Check the paper. Have we finished up everything? The Pascal principle. Pascal principle paper finished or not? Carline, have we finished or not? Can you check the paper, Carline?
Yes, sir, finished already.
All done already,
yeah.
Okay, thank you very much. Okay, then we start another new lesson today, Okay, I start sharing the paper with you. Okay, so it's right here. So you start another principle today, okay? Last lesson or last two lessons, we did this Pascal principle. The first principle you learn. Okay, now we move into another principle. This is Archimedes Principle. Okay, Archimedes Principle. The name is Archimedes. Also a name of a scientist, Archimedes Principle. Okay, what is Archimedes Principle now? So I don't want to explain so much first. I want you to look at this diagram. Just look at this diagram only. Okay. So this is spring balance. Young Jing Sun now coming in. Jing Sun. Anyone got stuck outside or not? Sometimes I cannot see one, I must click. Because sometimes waiter outside then say I never approve. Okay. This is a spring balance. So you have a load here. So you show that 40 Newton. This 40 Newton is an actual weight. Actual one. Hanging in the air, right? So this is 40 Newton is actual weight. So what happens is when you submerge into the water, you see when you start submerge into the water, you can see the reading of spring balance decreases, drop to 38. Drop by 2 Newton, If drop by 2 means down here got 2 Newton of force supporting the object. Sure got. If not, it would -2 up here one. Okay, so 40 reduces to 38, so -2, right? So meaning that over here got 2 Newton of force supporting the object, Okay, now these 2 Newtons of force is something like water. The force comes from the water, water trying to support the object so that the object can float. Okay, so this is called buoyant force. B-U-O-Y-A-N-T, buoyant force. Okay, or sometimes we say buoyancy force Okay, the floating force okay, buoyancy force. Okay, after that you submerge deeper inside. Now you see here, drop to 35, further drop to 35. So -5 now. When you 40 minus 35, you get 5, meaning that down here got 5 Newton of force supporting the object, So meaning that this buoyant force now become 5 Newton. From the bottom, support the object. So the reading here reduces by 5. Next, fully submerged now. You can see now, the object is fully submerged. Fully submerged, the reading dropped to 30 minus by 10. So meaning that the buoyant force here is 10 Newton. Okay? 10 Newton of buoyant force supporting the object, So it's like here minus by 10, so it becomes 30. Then after that, you notice, you continue to submerge it deeper, right? But it never changes, This reading remains as 30. You know why? Because the volumes of water actually the volumes of the object already fully submerged. So you make it deeper, also the same. Because the volume submerged inside the water remains the same. That's why the buoyant force will never change anymore. Buoyant force remains 10 Newton, maximum already. Okay, and then here 30 remains as 30 lah. Okay, now you need to know, from where these 2 newtons, 5 Newton, 10 Newton come from. Okay, so actually now all this buoyant force, right, come from the water displaced by the object. Because when you put the object inside the water, the object actually push aside the water. It push aside the water, isn't it? We say displace the water. Okay, so now what happened actually is like this, If this buoyant force is 2 Newton, means the weight of water displaced also 2 Newton. When it displaces 2 Newton of water, right, it will produce buoyant force of 2 Newton. In other words, means the buoyant force produced actually equal to the weight of the water displaced, not the volume of the water, the weight. For example, here, buoyant force 5 Newton, meaning that this object already displaced the weight of water of 5 Newton. 5 Newton of weight of water being displaced already, put aside. Okay? When fully submerged, right, so this load will displace the weight of water of 10 Newton. 10 Newton of water being displaced. That's why 10 Newton of water displaced, then you have 10 Newtons of buoyant force. And then when you further put down deeper, right, you notice that this buoyant force remains the same. Why remains the same? Because the weight of water displaced here and the weight of water displaced here are the same already. Because already fully submerged, fully submerged means you already displaced maximum water already, which is 10 Newton. So when you further make it deeper, same. The weight of water displaced still cannot change, still remains as 10 Newton. Okay, so in other words, means class, you have to remember this important concept, Any object you submerge into the water, right, there will be a buoyant force trying to support the object, and this buoyant force is equal to the weight of the water displaced. Equal to the weight of the water displaced. Okay, please highlight the concept here. This one, please. Archimedes Principle. Please highlight this one. This is very important. Archimedes Principle state that, okay, highlight here, put inside your brain this statement. When an object immersed in a fluid, okay, fluid means can be water, can be gas, okay. The buoyant force, or another name we call upthrust force. The buoyant force or upthrust force on the object is equal to the weight of fluid displaced by the object. So you read one more time the whole statement. This is a statement of Archimedes Principle. When an object immersed in a fluid, right, the buoyant force or upthrust force is equal to the weight of fluid or weight of the water displaced by the object. So the key word here I emphasize is the weight of the fluid, not the volume. Understand? In my experience or marking SPM paper, many students think it's volume, No, it's not volume. It's the weight of fluid displaced, weight of the water displaced. Understand? Okay, now? So that was about Archimedes Principle. Okay? All right. Now we look at the introduction here first. Okay, come back here. Okay, there are a few answers you need to fill up here. Okay, come. When object immersed partially or completely in the fluid, the weight of the object decreases. You can see just now, right? The weight decreases. And it is called loss of weight. 40 drop to 38, then drop to 35. So we call weight decreases, and this is called loss of the weight. Okay, number 2. The loss of the weight actually depends on weight of water displaced. Okay? The loss of the weight actually equal to the weight of the liquid displaced. And the last, number 3, the loss of weight is caused by an upthrust force exerted by the fluids on the object, and the force is known as buoyant force. Buoyant force, remember the term, or upthrust force. Two names are, you can either call it buoyant force or you can call it upthrust force. Okay? Upthrust means supporting the object to make the object to float. Okay? Upthrust force or buoyant force. And one thing you have to remember, when you take this actual weight minus all these 38, 35, 30, these are called apparent weight. Okay, can you jot down? All these weight are called apparent weight, not the actual weight. Actual is only 40. All these are called apparent. Apparent weight is something like fake one and not the real one. Okay, apparent weight. When you take actual minus the apparent weight, you get the buoyant force lah. You see, 40 minus 38, you get 2. 40 minus 35, you get 5. 40 minus 30, you get 10. Correct not? So actually, the buoyant force comes from the difference between the actual weight and the apparent weight lah. Okay, understand? Okay, now question time. When I call your name so quickly, you come out. Okay. Yu Tong, please come out. Yu Tong, where are you? Ngu Yu Tong?
Yes, sir.
Yu Tong, tell me what is Archimedes Principle. What is Archimedes Principle?
When the object is immersed in a fluid, the buoyant force on the object is equal to the weight of the fluid displaced.
Yes, correct. So remember this statement, This statement, you have to put it inside here, everyone, not only you Tong, everybody must remember in your whole life. Okay? I believe some of you now, I ask you what is Pascal principle, you already forgotten. Some, you have to be very focused because whatever principle like Pascal principle you learn, and now we move into Archimedes principle, so you don't forget the previous one, you still have to remember. Okay, Pascal principle, now Archimedes principle, right? Okay. Another question, let me call this who are Jia Wei, Yong Jia Wei, are you there? Jia Wei?
Yes, sir.
Jia Wei, How to get the buoyant force? How the object floating in the water produce a buoyant force?
Can you repeat, sir?
Okay, I repeat the question. When object submerged into the water, so you have buoyant force, isn't it? So this buoyant force actually come from where? Jia Wei? From where this buoyant force come from? There must be something, This buoyant force come from where?
The water displacement.
Yes, correct. Come from the weight of the water being displaced. Displace the water, but remember, it should be the weight of water displaced. Come from the weight of water displaced. Okay, thank you, Yong. All right. Okay, one more question I want to ask. Okay, now let's hear from Mr. Wennon. Wennon Teo, are you there, Wennon? Wennon Teo, Wennon, are you there? Wennon no more there, already disappeared. Wennon? Terry, there you go, are you there?
Yes, sir.
Terry, okay, one very tough question I want to ask you. What is apparent weight? What is apparent weight? Apparent weight is what?
Fake one.
Fake one, not the real one. It's the weight with the actual weight minus the supporting weight, supporting force. It's an apparent one. Apparent means not the real one. It's a fake one. Actually, apparent weight means it's a weight, it's a reading of the spring balance when the object submerges into the water. When you submerge into the water, you see the spring balance reading. That reading is called apparent weight lah. Okay. Okay, come next. Next, one relationship, very important one you see here now. Here show the spring balance reading 40, 38, 35, 30, and 30, right? And here show how deep you submerge inside the water. Here, submerge a little bit. Here, you submerge deeper. And then here, fully submerge. So you notice here now, the deeper you submerge the object, right? The spring balance reading become smaller. The deeper you submerge, it becomes smaller. Yeah, you see here, smaller. It's getting smaller and getting smaller because you go deeper and deeper, correct not? Right? Okay, so the graph, you need to plot something like this, the graph, okay? So it starts from 40. Here is the spring balance reading. Here is a distance from the lower portion of the submerged object to the surface of water. Means the depth, how deep you submerge it inside. Okay? So you can notice that the deeper you submerge, right, the reading becomes smaller. 40, 38, 35, 30, and then become constant. It become constant, because you see 30, 30 never changed already, right? Just now, no? 30 and 30 remains the same. Fixed already, never change. Okay? This is the graph photo. It never changes anymore. 40 drop to 30 and then become constant. Here getting deeper. Okay. I have a question to ask you all. Why here become constant? Why it become constant? What is the reason? Why it become constant? Why this buoyant force never increase anymore? Here is 10, here also 10, and then make here constant. Why? Why this buoyant force never increase anymore? Why? Kylie, can you try or not? Why this buoyant force never increase already? It become constant. Why?
Maybe the weight only 10.
Yes.
Maybe the weight only 1 kg.
The weight of this thing. Okay, can say like this actually. Why this buoyant force never increase anymore? Because the weight of water can be displaced already maximum because fully submerged already. So meaning that the weight of water can be displaced is already maximum. You submerge deeper, still the same because the size of the object is like that one. So the amount of water can be displaced remains the same. So weight of water displaced same, it won't change anymore. So the buoyant force remains the same. Okay, okay, I think you all can understand that one. Okay, next one. Please read this one. From this diagram show that when you put object floating in the water, right, you have buoyant force. Buoyant force is the force going up, buoyant force. Then you have weight of water displaced, weight of fluid displaced. Okay, what happened this thing submerged this much in the water, so the water can be displaced is like this, isn't it? So the weight of this water will equal to the buoyant force. In other words, means this buoyant force Fp equal to the weight of this water. The water be displaced is the same. So this is Archimedes principle. So okay, understand. Okay, another one is density and buoyancy. Okay, go straight to the formula. You have seen the buoyant force, right? Okay, now, since we say the Archimedes principle say, right, buoyant force actually equal to the weight of fluid displaced. So the weight is mg, we learned before, weight is mg. So the mass can be replaced by rho v, density volume, because from here, density equal to mass divided by volume. Okay, so mass is rho v, rho multiply v, so you put it here. So it becomes a very famous formula. buoyant force equal to rho Vg. So meaning that how big or how small the buoyant force, right, depends on the density of the water being displaced. This one must be density of the liquid or the fluid being displaced. You cannot simply put any density put inside here. No, it must be the density of the water, because density comes from the liquid, from the liquid displaced, right? So you must use the density of the liquid being displaced. Same thing goes to the volume. Buoyant force comes from the liquid displaced, so it must be the volumes of the liquid displaced, volume, okay? And last, of course, is gravity. So from this formula, it's very clear, we see, right? The buoyant force relies on the density of water display, relies on the volumes of the water displaced, okay? And also relies on the gravity, okay? So there are three things affecting the buoyant force, density, volume, how much water you displace, volume, and last is the gravity, okay? And before this class, you also learn another formula, right? You see this formula, rho H, okay, sorry lah. Rho Hg, H and G. Can you tell me that this formula is very near to this, rho Vg, this is rho Hg. This rho Hg is for what? You remember this formula or not? Rho Vg is buoyant force, then rho Hg is what? Huh? Yeah, someone give the answer already. Justin Yip say gas pressure. Gas pressure lah. I think we have a better answer, Rho Hg actually is what? Huh? Please answer. Try again, everyone. Type your answer. You want to talk, you don't mind, you type the answer. Formula of rho Hg actually is what? To calculate what, man? Justin again, pressure in the liquid. Yes, this time you are perfectly correct. Justin, is liquid pressure. Actually, rho Hg is to find the liquid pressure. Liquid, I put L here, liquid pressure. Okay? So make sure you don't confuse these two formulas. To find liquid pressure, you take rho Hg. H is the height of the liquid or depth of the liquid. To find buoyant force, you take rho Vg, okay? So remember these two formulas. Don't confuse yourself. Caroline, okay, understand?
Okay, sir, understand.
Understand, And how about this, Who already, The Dylan not here, no? Chu Hongxuan. Do you understand not? Chu Hongxuan. Do you understand the formula, Chu Hongxuan? Understand, Okay, to find buoyant force is rho Vg. Okay, come, now answer this question. Use the formula, calculate. What is the answer? Your calculate, please. Show the answer, please. A metal sphere has a volumes of 5 times 10 power negative 4. The volume of the ball. Then the ball immersed into the water. The density of water is 1 times 10 power 3. So determine the upthrust. Upthrust means the buoyant force. So use the formula rho Vg, direct calculation. So what is the answer you get? What is the answer you get? Angel Ng, what is your answer? Angel, where are you? What answer? 5. Yes, correct. 5 Newton. Okay, thank you, Angel. Rho Vg, you calculate, you get 5. But unit must be Newton because this is force. Buoyant force, as long as this is force, so the unit must be Newton. Okay, So quite simple, the calculation rho Vg. All right, now, example 2. This is a difficult question. You see what you need to do here? Okay, think first, okay, you all. A wooden block density. Now in these questions, there are 2 density, One is the density of the wood. Another one is the density of the liquid. So you have to be careful. A wooden block with the density 4 times 10 power 3 and the mass of 5 kg, the wood 5 kilogram. Immersed in the liquid, density 1 times 10 power 3. The density is 1 times 10 power 3. Calculate the buoyant force acting on a wooden block. They ask you to find the buoyant force. So far, you know, like buoyant force only one formula, rho Vg. So you need to find the rho Vg. Okay, now first thing, you see this formula. Density, mass over volume. So I find volume. Volume is mass divided by density. So now I put the mass of the wood, 5 kg, divided by the density of the wooden block. I get the volumes of wooden block. Why I go and find the volumes of the wooden block next? Why? Actually, we should find the volumes of the water displacement, but here we are finding the volume of the wood. Why? Why we can find the volume of the wood? And then you see, put in the formula. Actually, we are using the volume of the wood to put in, You see here must be density of the fluid, density of the water. Because remember, buoyant force come from the water one. So here, this rho density must density of the water or the fluid displaced. Volume here, 0.00125 actually is the volume of the wooden block. Why can put inside here? This is supposed to be volume of the water, Why can I use these volumes of the wooden block? And gravity, no argue 10 Why? Can someone answer my question or not? Just like I say, right? To find buoyant force, density must be the density of liquid. Volume must be volume liquid displaced. But here, I don't use the volumes of liquid. I use the volume of the wooden block. Why? Why I can do that? Caroline, can you answer now? Why? Why I can use the volume of the wooden block? Caroline? Why?
Yes, sir.
Why I can use the volumes of the wooden block? Vivian, okay, Vivian, can you try? Vivian, why I can use a wooden block volume here? Why not the volumes of water? Vivian?
Because the wooden block immersed into the water.
Yes, once again. One more
Because
time.
the wooden block need to immerse into the water.
Oh, yeah, that's why you can use a wooden block punya volume lah. When say question ask wooden block, no. The question never ask wooden block, ask you to find the buoyant force le, Venom. Okay. Anyone can explain, actually very straightforward, why we can use the volumes of the wooden block? Tan Choming, why can use a wooden block punya volume here? Choming?
Maybe because the weight of the wooden block is equal to the buoyant force.
Oh, like that not really Hashini, how you think, Hashini? Why I can use a volume of wooden block here? Hashini?
Same, master.
Yeah lah, this one. Same lah. Actually, the volumes of the wood, when you submerge into the water, so the volume of water displays exactly same like the volume of the wood. Correct? Not it's the same one. You see the piece of wood the volume this big. When you put inside the water to displace the water, so the volume of water displaced must be the same as the volume of the object. That's why in this case, volume of water displaced actually exactly the same as the volumes of the wooden block. Like Hashini say, understand you all? Same one, Vivian, understand or not?
Understand?
The volumes of the wooden block, same as the volume of water displaced, is the same one. That's why you get this answer, 12.5 Newton. Okay, So this calculation, okay lah. Okay, now we move to the next question. This one is very straightforward, direct. Object has a weight 40 in the air. This is actual weight. And 36 Newton in a liquid. When you put inside a liquid, it drop to 36 means this is apparent weight lah. Okay. Density of the liquid is 800. Determine the volume, so straightforward lah. You see here can already. Buoyant force, you know, is 4 already. You take 40 minus apparent weight 36, so you get 4. So this 4 must be the buoyant force. So the buoyant force is rho, density of the liquid, 800. Volume, you don't know, you're asked to find. Gravity is 10. So you get 5 times 10 power negative 4 meter cube. So this is the volumes of the object. Okay. Once again, you see now, volumes of the object actually same as the volumes of the liquid. It's the same one. When you fully submerged already, it's the same lah. Okay. Same So far can understand everyone. I keep on talking. Then when I talk more and more, people sleep, or you just go away to leave your handphone. Let Mr. Tam talk. Nobody care. Nobody listen. Is it like that? Justin say can. Only one Justin answer only. Okay,
I understand, sir.
Okay. Kevin, thank you. Okay, next, buoyant force and flotation. Law of flotation. Wait, I will look at this one first. This one very common sense. When the object floating, right, there are two forces, remember that. One is a weight, W. One is a FP, buoyant force. So the buoyant force always go up one, you know. So you draw arrow up here. This is buoyant force. The weight is down. Okay, now you see. When the buoyant force equal to the weight, when this one and this one same, right? So balance lah. Balance means the object not moving lah. So object float and stationary. So remember that, This one always ask one, you know. When the object floating, not moving, right, means the forces are balanced, the weight and the buoyant force same. Okay, second, when the buoyant force bigger than the weight, so the object will go up. Okay. This force, buoyant force, larger than the weight, larger than the weight, so you will push the object go up, so the object will go up until reach the surface of the water. Okay, and last one, this one please change to smaller. When buoyant force smaller than the weight, smaller, so the object will sink. Buoyant force, the weight, when the weight bigger than the buoyant force, or if you say buoyant force smaller than the weight, so the weight will make the object continue to sink deeper, it go down. Okay, so these three situations very simple, okay. And one more. Now, just now, principle. Now, law of flotation. Can you read the segment and then understand it? What it say? Just now, Archimedes principle. Just now was principle. Now, law. Law of flotation. A floating object displaces its own weight of fluid in which it floats. So meaning that any object floating in the water, right, this object displaces its own weight. Meaning that, for example, this object, 50 Newton. Let's say this one is 50 Newton. 50 Newton means this object must displace 15 Newton because it says displaces its own weight. When the weight is 50 Newton, it must be displaced 15 Newtons of water. Or we say it's a buoyant force, correct not? Object displaces its own weight. Weight 50 Newton, it must displace 15 Newtons of fluid, which is equal to the buoyant force. But one thing different, you know, law of flotation never implement the terms buoyant force. You never say buoyant force. You only say object displaces its own weight, but you never say the terms buoyant force. Whereas Archimedes principle, straight away say buoyant force. object submerged in the water produce a buoyant force. So the buoyant force equal to the weight of water displaced. This is Archimedes principle. So Archimedes principle is straightforward, say buoyant force equal to the weight of water displaced. Whereas law of flotation, you never say directly, you say object displaces its own weight. Its own weight lah. Okay. For example, let's say a durian, let's say 200 Newton. This durian drop into the water and then slowly it will float, right? The durian will float lah, slowly lah. So when a durian is floating in the water, right? So the durian must displace 200 Newton of water. Displaces its own weight, ma. Another example, one big cargo ship. The ship is very, very big, huge one of the. Okay, the ship, let's say the weight is 1 million tons. Very, very big ship, cargo ship, 1 million ton. Meaning that this 1 million ton ship must also displace 1 million tons of water. Can you imagine how much water need to displace by the big ship in order to float? Not easy, The law of flotation is correct one. If the ship is 1 million ton, means 1 million ton of water must be displaced. That means how to displace 1 million tons of water, okay? The only way can do is the cargo ship must be giant size, very, very big size, very huge. Then only when it's submerged into the water, it can displace a lot of water until 1 million ton. Again, that is a concept of shipping, shipping industry using Archimedes principle. Okay? All right. Can you answer example 4? Simple question. Okay, answer this question. An object 5 kg floats on the surface of water. What is the upthrust? Very straightforward answer. What is the upthrust? What is the upthrust? Cecily Chin. 5 kg object floating. Now, what is the upthrust experienced by the object? What is the upthrust of this object? Cecily Chin?
50 Newton.
Yes, correct, 50 Newton. 5 kg, so the weight is 50 Newton. No? That's it. Okay, just find the weight only because object displaces its own weight. That's all. Okay, displaces its own weight. That will become the upthrust force or buoyant force. 50 Newton. Okay, Okay, next one. Next one, just go through quickly. Just a few examples. They ask you to write the relationship. Okay. Write in words the relation between. Okay, here you write in words. Over here got two forces. One is a weight. One is a buoyant force. So you write weight of the sphere equal to the buoyant force. Okay. Weight of this sphere must equal to the buoyant force. Okay, the second one, here got weight of the load plus the shape of the boat, right? Got two. One is the weight of the boat and also weight of the load must equal to the buoyant force. Weight of the load plus the weight of the boat equal to the buoyant force. And this one you write yourself. Okay, over here, how to write this one? How to give a statement for this one in words? Kevin, can you give answer for this, Kevin? Weight of what and what equal to what and what? Kevin Lim?
Wait, sir.
Okay. Just see the diagram. See the diagram, you know the answer already. How to write in sentence?
The weight of glass tube and lead shot is equal to the buoyant force.
Yes, correct. The weight of the lead shot and the glass tube. There are two, right? The glass tube plus the lead shot. The weight of the glass tube and the lead shot must equal to the buoyant force. Okay, correct. Thank you, Kevin. And the last one, can someone please give the answer? Okay, let me call someone to give lah. Singru, Tan Singru, are you there, Singru? Singru, Tan Singru, still there or not? Singru no sound already. Okay, Cheris Lim. Cheris Lim? Huh?
Yes, sir.
Okay, Cheris, can you give us statements on this diagram, Cheris Lim? Take your time, Cheris. Can? Cheris? There are load, balloon, and helium gas. There are three things here, you know. And these three things must be balanced by the buoyant force. So, Cheris, how to give answer?
The weight of load and balloon is equal to the buoyant force.
Helium gas got the weight one or not? Cheris?
Weight of load and balloon.
Helium gas got weight or not?
The weight of balloon and load is equal to the helium plus buoyant force.
Okay. The loads of the weight of the load and the balloon and the helium gas, because the helium gas is also got, the balloon itself got weight, and then the helium gas also got weight one, a little bit also got weight one, you know. Even though helium gas is very, very light, but it still got weight, got a little bit now. So the weight of helium gas, balloons, and the loads, right? Three things together equal to the buoyant force, okay? So remember now, the weight of the helium gas and the weight of the balloons and the weight of the load equal to the buoyant force. Okay, so understand, Mei Hui, understand? Yi Mei Hui, Menti Te. Understand these two sisters. They must together one, you know. Mei Hui and Menti, both of them say yes. They answer also at the same time one, you know. Timing, everyone same one too. Okay, come look at example 5. Okay. Give yourself a little bit time to understand it. The figure shows a glass tube. This is a glass tube, 0.012 kilogram. Uniform diameter, mean the diameter uniform one, and the cross-section area 4 times 10 power negative 4. Meaning that the cross-section area of this glass tube is 4 times 10 power negative 4. This is filled with the sand. Put a little bit of sand here. Actually, we put sand inside here is to make the bottoms of the glass tube heavier. When bottom of the glass tube heavier means when it float in the water, right? So the glass tube will stand vertically. It won't topple. Because the bottom part is heavy. Heavy means it will stand upright. It won't topple. Okay? That is the purpose of the sand. SPM also came up before. Why? They ask you why put sand or why put lead short? Okay? So now the question. Density of water is 1,000. First question, find the upthrust. So how to find upthrust? How to find the buoyant force? For sure, you know got buoyant force one. This buoyant force support the thing, right? 0.32. Justin already give the answer. So fast he give the answer already. Okay? Yes, correct. Justin answer is correct. 0.32. Okay? All right. First, I'll tell you what. You have to find the volumes of water displayed. Because rho Vg, the rho density is 1,000 given, right? Water 1,000. But the volumes of water, we have to calculate yourself, Volumes of water. How to find the volume of water? You find the volumes of this test tube. Meaning that this part only you find the volume of this part. Okay? Which the height 0.08 lah. So to find the volumes of the test tube, right, you take base area multiply the height, not this formula. Lo. Base area multiply the height. Base area given already 4 times 10 power negative 4. The height 0.08. So you put here, you get 3.2 10 power negative 5 meter cube. So this is the volumes of the test tube submerged in the water. And also here, same as the volume of water displaced. So you can put here. Gravity is 10, so you get 0.32 Newton. Means the buoyant force is 0.32 lah. So this buoyant force of 0.32 actually are supporting the whole thing, Supporting the sand and also the glass tube. Two things are 0.32 support the sand and also support the weight of the glass tube. So now next question, they ask you to find the sand, mass of the sand. How to find the mass of the sand? Think of it, everyone. So how to find the mass of the sand? Anyone got an answer or not? If you got the answer already, share your answer. Anyone got it?
0.02 kg, sir.
Yes, correct. Very good. Kevin? Yes, you are right. No, like that. You find the weight of the sand. To find the weight of the sand, you take 0.32 because buoyant force 0.32 means the weight of the whole thing also must be 0.321. So you take 0.32 minus the sand. Sand 0.012 kg means 0.12 Newton no here. The glass tube, sorry. This is a mass of the glass tube. So when you multiply 10 Newton, you get 0.12. So this is the weight of the glass tube. Total weight minus weight of glass tube, so you get 0.2 Newton. This is the weight of the sand. Okay, weight of the sand. Okay, weight of the sand. So once you get weight of the sand, you can find weight of the mass of the sand divided by 10. Right, you get 0.02 kilogram. Okay, trying to figure out it now. Make sure you understand. I said it again one more time, you all listen in case you miss it just now. After you calculated, you get the buoyant force is 0.32 Newton. You must know, object displaces its own weight means buoyant force is 0.32 means the weight of the glass tube plus the weight of the sand must equal to 0.32. Now to find the weight of the sand, you take total weight 0.32 minus the weight of the glass tube. Glass tube mass given. When mass given, you can find the weight multiply 10. So you get 0.12 Newton. This is weight of the glass tube. So you minus, you get weight of the sand 0.2. Now you are asked to find the mass of the sand. From weight to find mass, you divide by 10. 0.02 kg. Okay? Can understand? Huh? Take your time, take your time to go and understand it, Tak Chang, do you understand? Tak Chang?
Yes, sir.
Can I understand? You Tong, do you understand?
Yes, sir.
Okay. Yong Si, Lo Yong Si, understand?
Yes, sir.
Okay, very good. Lim Ching Wen. Where are you, Lim Ching Wen? Do you understand?
Yes, sir.
Good. First time you answer my question, Lim Ching Wen. Zhu Hong Xuan, understand? Zhu Hong Xuan, he replied already. Come, let me see what he say. Yes, he say yes. Yes means understand. Cho Ming, understand? Tan Cho Ming?
Yes, sir. Understand.
Okay, understand. What about this Mr. Darren? Darren To, do you understand? Mr. Darren To, understand? Darren? No, he typed. So he say what? He say yes, sir. Then your good friend Yong Ching Han, understand? Where's a good friend Yong Ching Han? Yes, Ching Han. Okay, come, we move to the next one. Next is application. Now you see in these things, right? Every time you learn the principle, the concept, you learn a little bit of calculation of the principle, right? After that, one most important one is application. At what field this principle you learn use? For example, like Pascal principle you learned the other day, right? You learn the formula. After that, most important is you learn the concept how to use the Pascal principle. You have already learned in lift pump, hydraulic pump, hydraulic brake system, all these things, right? Okay, make sure you remember it, okay? All these are the application of Pascal principle. Okay, I tell you physics cannot run away from engineering one. You learn physics is meant for your future to become engineer, not to become engineer and also become a doctor. Why I say doctor, because machinery, the advance of this machine for in the medicine field, you need people very good in engineer to be a doctor. That's why in America, you want to study medicine in America, they don't look at your bio one, look at your physics. Not like other countries. Because our country follow the foundations of British system. British system, they're more based on biology. Okay? But because lately, these are 10 years, in a 10 years time of this, right, because the medicine field already developed so advanced now, the machine become more important already. Machine to diagnose, to do operation, whatever thing. Okay, the machine become very, very advanced now. Meaning that a doctor, actually they should know how to operate the machine. A doctor don't know how to operate a machine, don't understand the concept of the machine. You can't do diagnosis already, doctor. That's why now physics become more important. Physics and chemistry actually more important, too. Bio just like something, how to say, memorize one. You study this one, you memorize this, study that, environment. Now more and more involved in environment already. Okay? Okay. I don't want to talk so much. Later on, the bio teacher come and scold me. Okay, come. Application of Archimedes Principle. Okay, Archimedes Principle. First application is in the ship. Big ship, I don't say the small ship. In the big ship, when you look at the body, okay, body of the ship here, there's a mark here, they put a mark here. So this mark being enlarged, you can see many lines here. DF, F, T, S, W, W, and A. I see right here. TF is tropical fresh water. Tropical fresh water means the river water in a hot country like Malaysia lah. In our country is considered tropical country. Fresh water means the river water lah. Okay. And then fresh water means river water in other country, not tropical country lah. In China, in US, Russia, all this. Then tropical salt water means sea water lah, in the hot country like Malaysia. Tropical salt water. And then you have salt water in summer, follow the season, you know, summer. Then salt water in the winter different, okay? And of course, the last one is winter in North Atlantic, okay? So now look at the level here. This line show the level where the ship will sink, you know. Okay, hold on. Let me, my laptop no battery. I need to charge it now. Okay, I plugged wrongly already. Okay, hold on. Okay. I said it again now. The line shows where the ship will sink. The level where the ship will sink in different area around the world. Okay, you see here now, the highest line means the ship sink the deepest lah. Deepest is this level, tropical fresh water. It will sink very, very deep inside, you know. That's why the line here very high. High means the ship sink very deep already. The water level is here lah. Means the ship sink very deep long. Why? Why in tropical fresh water the ship will sink the deepest is because density of water very, very low. In a river like in Malaysia, right, or in Brazil has the same weather with us, tropical. Amazon River. Our Malaysia here, tropical country here, we don't have big river lah. Don't have big river, so not many big ship can come into Malaysia. River is okay, but country like Brazil, for example lah, they have Amazon River. Amazon River is like a sea, you know, very, very big one, you know. Okay, then the Brazil, the country built their port, the harbor inside near the river, not near the sea one. So their harbor or their port are in the Amazon River. This water dangerous because all the ship go into Amazon River now will sink very deep. Because the density of the water over there is very low. Fresh water density lower, you know lah. Okay. Some more is tropical. Tropical means the water is hot. When the water is hot, density become lower. Okay. Second level is fresh water lah. For example, in China, in America, this kind of country, the river water lah, fresh water. Okay. So second level means sink until here quite deep also, you know. And then third is tropical salt water. Salt water means sea water in hot country like Malaysia. I see salt water, the ship sink until here. Slightly better compared to the fresh water because sea water density is higher, right? Higher density. So the ship won't sink so deep already. Okay. Water higher density, so the ship will float higher. Okay. And followed by salt water in the summer. Summer means hot. And then salt water in winter, you see the difference or not? In summer, the salt water, sea water is hot, so the density lower, it will sink deeper. In the winter, cold, very cold, like during the winter, the sea water actually density is high, you know. Shouldn't the ship will sink one, you know. In the salt water during winter, ship shouldn't sink one because during winter the sea water density is very high, so the ship very easy to float, not easy to sink. But what happened to Titanic? There was Titanic is a true story, you know, not a fake one, no. Of course, a love story in the movie, not the true one. The sinking of the ship of Titanic, memang is correct one, is true one, no. You all know the Titanic ship or not? The biggest ship claimed by the company, right? In their first sail, you know, from UK, one go to US, right? Then it sink at this water, salt water in winter. During winter, the ship sink, you know. You know where this ship sink or not? Tak Chang, you know or not? Titanic, where the Titanic sink?
Not pretty sure.
Where?
I don't know.
You don't know one. You watch the movie or not?
I
Titanic.
never watched before actually.
You ought to know. Titanic, this is the most famous, most famous movie in the world. You ought to know the movie, huh? Maybe you're still young at that time, still small, like baby. Okay, this movie is very, very famous. You know, the whole world, everybody go and watch one. Sure, watch at least 2-3 times on this movie. Okay, love story of a young couple during the first sail of the ship, follow the Titanic ship. You know, wanted to go to United America, halfway sink already near this north, hit this area winter in North Atlantic, near the Arctic, Antarctica, the area. Because they never think the ship will sink, man, you know, the sail, they go too fast, and then collide with the iceberg, become the worst. It wouldn't sink, man, you know. It sink because the ship collide with the iceberg. The iceberg, the big ice are floating inside the water, cannot see one, you know, at night. So they knock the hit on it. Once a hit on it, the ship leaked already, so the water came in, become heavy, then it sink, very sad, Then the boyfriend died already. Okay, the boyfriend died, so the young girls continue to sail, people rescue her, then send her to America. It's a true story, you know. This old lady, they become old lady already, you know. These young girls, so recall back what happened. So this is a true story. That's why a lot of people watch the movie. Okay, Titanic. It's a nice love story, You Tong should go and watch. Okay, come. You Tong, are you there?
Yes, sir.
You always watch movie. You go and search. Titanic is a very famous movie. Okay. Okay, come. No joking only. Okay, come. A ship through very heavy floats on surface of the sea. This is because the ship can float in the seas because the buoyant force equal to the weight of the ship. So meaning that the ship able to generate so much of buoyant force to support the ship, you know. The buoyant force acting on the ship is large enough because the ship is hollow. I told you just now, right? In order to generate so much of buoyant force to support the ship, right? It needs to displace so much water. How to displace so much water? Because reason is the bottom part of the sea, I tell you, bottom part of the ship. Actually, when you look at the ship like this, actually the part sink in the water actually very big one, you know. Actually, only 1/4, 1/4 parts are above the sea water. 3/4 of the body of the ship is inside the water one, you know. That's why the size of the body of the ships submerged in the water is huge. The purpose is to displace more water to produce bigger buoyant force. And how to make it bigger? The bottom part is hollow. Hollow means empty one. Empty one, you know, hollow. Okay. So make it bigger, hollow, and then it can displace more water. Okay. The ship is hollow and volumes of water displaced by the ship is sufficiently large. Okay. Buoyant force is rho Vg. The density of seawater also varies with the location and season. I see. Density of water also changes, right? According to location. For example, tropical country, cold country, the density also different. And also based on the season, summer, winter, different, right? So remember now, the seawater, the water around the globe is having different densities based on their location and based on the season, okay? So to ensure the ship is loaded within the safe limit for safety purposes, this line is called plimsoll line. Please highlight the term plimsoll line. Plimsoll, P-L-A-I-M-S-O-L-L, plimsoll line. He mark on the body of the ship, act as a guide, guidance, okay? So meaning that the pilot must know, okay? The pilot of the ship must know this area, the ship will sink. This area, the ship will float higher, they will know. So they need to unload some of the things. For example, like cargo ship wanted to come into Malaysia already. Malaysia is a tropical country, right? So the ship shouldn't carry so much of load already, because when come into Malaysia, especially river in Malaysia, right? So the water density is low, so the ship will sink very deep, sink until here. So what this pilot they do, they can reduce some of the load, okay? Reduce the load before enter fresh water in Malaysia. That's the guidance for the people, okay? So remember the first application of Archimedes Principle in the ship, plimsoll line, okay? All right, next one is submarine. Submarine, you see there are three diagrams here, 1, 2, 3. Okay, submarine is like this, Actually, the submarine, the body surrounded by tank, water tank. So we call it ballast tank. Ballast tank means a lot of tanks surrounding the body of the submarine one, When you look at the body of the submarine, you think it's very big. Actually, no, they are empty one, all a water tank. Got surrounded by many water tank. So we call it ballast tank. Okay? When the ballast tank is empty, so the submarine will float stationary. Why? Because when this ballast tank empty, right, means not heavy. Not heavy, so it will float. Okay? When the submarine wanted to dive inside, go inside the sea, right? So the pump, I will on the pump the water inside to fill up the ballast tank. Okay? There's very powerful pump inside the ballast tank. So it will pump the water when half fill up the ballast tank, half fill up. So it will start to sink sink half only. Okay? When a ballast tank is fully filled up with water already, pump all the water fill up already, so it become too heavy. Too heavy means it will sink into the bottoms of the sea. Okay, that's how the submarine float and sink one, by pump the water inside or remove the water. You see, so meaning that this submarine need to have a lot of this water pump. Wanted to sink, it pump the water from inside, so make it heavy. Heavy, it will sink. Pump more water inside the ballast tank, so we sink very deep, right? Okay, when we want to float, so we on the pump again, but this time the pump is remove the water. Remove the water. It cannot open the hole, the water won't go out because the water pressure is so high, so you need to use a pump. There are two pumps here, One is to pump the water inside. The other one is to pump the water go out. Two different pumps class. Two systems. One is to pump the water inside. The other one is to pump the water go out. Okay? When you want to go up, floats, right? So you pump the water out lah. So when the water less already, so it become lighter. So slowly it will go up. Okay. So this is, you see the advance of technology, how advanced the technology are using the water, pump the water in to sink, remove the water to float, understand? But this technology our countries also still cannot do. We cannot create our own submarine. Not even say submarine, car also we are not able to produce fully yet. To produce a car, we still need other country to come here. Okay. So our country future is in your hand. So work hard, everyone. Kelvin, all these people, Kian Leong, become engineer later on. Go and design submarine. Okay. Submarine can sail on the surface or underneath the water. Its outer hull means outside the body here, entirely watertight. Water cannot go in one, waterproof. Inside the hull are numbers of tanks, a lot of water tanks, we call it ballast tanks, which is used to control the positions and depth from the surface of the sea. Highlight, if ballast tank is empty, the ship very light, so it will go up lah. Up thrust equal to the weight, so it will float stationary. When a ballast tank is full, up thrust less already because the weight bigger, right? Full water, so very big, the weight very, very heavy already. So the up thrust now smaller than the weight, so it will sink. So remember, this is how the submarine work, float to sink using ballast tank. Fill up the water or ballast tank, so it will sink. Empty the ballast tank to reduce the weight, then it will go up. So submarine, understand?
Yes, sir.
Kevin understand. Amy understand. Amy Tan.
Yes, sir.
Okay. Kylie understand. Kylie Wong.
Yes, sir.
Can Yao Shi understand?
Understand, sir.
Okay, good. Tai Kalok, do you understand? Tai Kalok.
Understand, sir.
Can When understand Palestine, understand the submarine or not?
I understand.
Understand, Vivian, what about you? Vivian Singru?
Understand, sir.
Can Okay So next one, hydrogen fuel balloon. Hydrogen fuel balloon. Okay. The hydrogen fuel balloons I'm sure you know, right? There are certain balloons when you let it go, sure it will fly up one. That kind is called hydrogen fuel balloon. So the balloon is filled with hydrogen gas, The hydrogen gas is very light, so it will float. You will fly up into the sky. If the balloon, you go and blow yourself, you blow, you let go, it won't go up into the sky one, because full of carbon dioxide. Carbon dioxide is heavy. Hydrogen gas is light, okay? But based on what concepts the hydrogen fuel balloon will fly, into the sky, you see here. These hydrogen fuel balloons also got two types of forces. One is a weight, another one is a buoyant force, upthrust force. Only two forces, the weight of the thing and the buoyant force. Okay, now, from where this buoyant force come from? First question you all must ask already, why got buoyant force one? This one not in the water, why got buoyant force? Yeah? Because when you pump, you inflected this balloon, right? It become bigger, so it will displace air. So you see here, weight of air displaced. When you displace air, you have weight. So this weight turns into the buoyant force. Okay? This one you see here, buoyant force equal to the W. The W is here, weight of the air displaced. Because when this balloon go bigger, right, it will displace the air. weight of the A displaced will be equal to the buoyant force. And because of buoyant force equal to the W1, when they are equal, means this balloon floats stationary, not moving. When you want to go up, the buoyant force must be bigger lah. How to make buoyant force bigger, class? Can you tell me or not? Okay, now I say now, when buoyant force equal to the W1 equal to the weight, when this one equal to this, so this balloon won't fly one. It will float stationary there in the sky. How to make the buoyant force go higher, go up? How to make it? What you must do? Huh? How you can make a hydrogen gas balloon fly higher? Very good question. K-but question. If someone say want to make this hydrogen gas balloon now fly higher, so what you must do? What you must do? Kian Leong never say anything today now. Kian Leong, can you please come out? Kian Leong can speak louder and put your mic nearer to your mouth lah. Kian Leong?
Yes, sir.
Kian Leong I'm asking you how to make this balloon go higher. How you do it? How you want to make this balloon can fly higher one?
Decrease the weight.
How you decrease the weight? We have a better way to make the balloon fly higher, you know. What is a better way?
Increase the hydrogen gas amount within the balloon.
Decrease or increase?
Increase.
Make it bigger lah.
Oh.
Yes, correct. Very good. Actually, you put more hydrogen gas inside, so the balloon become bigger, correct not? When the balloon become bigger, it will displace more air, more air will be displaced. Bigger already, so it displaces more air. When more air displaced means the weight of the air displaced become bigger, so the buoyant force bigger lah. So when buoyant force bigger, it will go higher. Okay? The hydrogen gas actually, the more gas you pump inside, it won't change the weight of the balloon so much one because hydrogen gas is very light. You pump a lot of hydrogen gas inside, the weight won't change so much. Okay? You only make the balloon become bigger. When the balloon bigger, right, definitely it will fly higher one because it displays more weight. Air displays, weight of air displays become more. More it will fly higher lah. Buoyant force bigger When buoyant force bigger than the weight, so it will fly no. Understand Vivian, understand? Vivian? Carline, all these people understand one or not? Vivian? Carline, do you understand?
Yes, sir.
Carline, okay, So this is hydrogen filled balloon. Okay, you read a little bit here. Come, read here. This one read yourself. This something about the hydrogen filled balloon. Read it yourself. Hydrogen filled balloon float up in the air. A is a float and produces upthrust. Okay, density of A bigger than the density of hydrogen. The balloon floats and rises because upthrust bigger than the weight of hydrogen and weight of the balloon plus the weight of the string. But he never say where to come, from where the upthrust come, he never explain. So I told you to jot down already. When the upthrust, the buoyant force come from the weight of air displaced, right? Bigger than the weight of everything now, so it will go up. The balloon remains stationary when upthrust equal to the weight of everything now. Okay. So that was a hydrogen-filled balloon. Okay, now one more. This is even more important. It came out many, many times in the SPM. This is hot air balloon. Hot air balloon. Hot air balloon, I'm sure you've seen it before, right? Okay, you need a gondola here or something like a basket lah. So people will stand here, right? So you need this a Bunsen burner, something like a burner lah. When you want to go up, you need to start the fire to heat up the gas inside. Why when you want to go up, you need to start the fire to heat up the air? Eh? Okay, simple reason now. When you heat up the air inside, so hot air will expand. Okay, when you heat up the air, right, the hot air will expand. No? So you make the hot air balloon bigger, expand when hot. The whole thing will expand. No? When you start the fire to heat up. When this thing become bigger, right, so it will displace more air. Weight of air displaced become more, right? So the buoyant force becomes stronger. The upthrust force stronger. This side, it will go up. So when you want to go up, you heat up the gas to make this balloon bigger. Like just now, like the balloon bigger. When it becomes bigger, it displaces more air. When more air displaced means bigger buoyant force. When the buoyant force bigger than the weight, right, it will go up. Okay? By using the fire to control the position, actually. But usually the hot air balloons are sometimes you go up already, then you need to stay static for people to look around, take pictures, right? How to make the hot air balloon floating stationary? You reduce a little bit of the fire. Okay? Reduce the temperature of the gas law. When reduce the gas temperature drop a little bit, right? So the balloon size becomes smaller a little bit. So buoyant force slightly smaller. So when the buoyant force same as the weight, so it stays stationary lah. What about when this hot air balloon wanted to come down? How to make this hot air balloon come down? Huh? You switch off the fire actually. Off the fire. Don't on the fire anymore. Let the gas here cool down. When the gas inside cool down, so it will contract. So the balloon becomes smaller lah. When balloon becomes smaller, weight of air displaced become less. Then the weight now become bigger than the upthrust already. So it will descend slowly lah. Okay, okay, come, we go through one by one. Density of hot air less than the density of cold air. This one you know. Hot air less dense one when you heat up. The balloon's height can be controlled by turning the gas burner with heat the air on and off as needed. When you want to go up, you heat up the gas. When you want to come down, you don't burn, you don't heat up the gas, that's all. Hot air balloon floats and rises when upthrust bigger than the weight. Okay? The balloon descend means come down when the upthrust smaller than the weight. But here's once again, it never explained from where the upthrust come from. I told you here already, please jot down the remarks here. The upthrust come from the weight of the air displaced. When you heat up the gas, the balloon bigger, it displaces more air. So buoyant force, upthrust bigger. So it go up, okay? Upthrust smaller than the weight, so it come down. Balloon remains stationary when upthrust equal to the weight of everything. So this is how hot air balloon works. Understand? Okay, 2 minutes for you to read everything and then I ask question. Okay, all the application. Okay, ship blind line, submarine, hydrogen-filled balloon, hot air balloon, and one more hydrometer. The hydrometer I will come to you later. Okay, you read this 4 first. Okay, come. Okay, class. Okay, don't worry. I just want to ask a few questions only. So when I call your name, so you come out lah, please. Choming, Tan Choming, are you there? Tan Choming?
I'm here, sir. Yes.
Yes. Tan Choming, what is prime soul line? Prime soul line is for what purpose?
The purpose is to mark on the body of the ship as a guide.
As a guide lah,
The line.
As a guide for the ship to sail safely lah, What is the reason? Okay, thank you. Okay, Choming, thank you. Okay, next question. Kylie Wong. Kylie, can you come up, please? Kylie.
Yes, sir.
Kylie, why need prime soul line? Why need prime soul line? Why
To
we
ensure the ship is located within safe limits.
Yes, why? Why need that? Why the sea is not safe, man? Why we need this prime soul line? Not safe, sailing in the river, sailing in the sea, not safe one. So why? Why not safe?
Because the density of the seawater depends on the location and the season.
Yes, very good, very smart, Kali. Because the density of the water, right, in the whole world actually not fixed one, From place to place, the density can be varies, can be changed one, From country to country, the density change. Okay, location and then for season also, winter summer the density all different one. That's why we need the extra precaution the prime soul line needed Okay, next question. Hashini, are you there?
Yes, sir.
Hashini, can you explain how submarines sink into the seawater? How the submarine can sink into the deep sea? I think her line not so good. Doesn't matter. I wait for her to come in first. Okay, now I ask another one to Caroline. Can you answer? She coming back again. So Hashini, you are back already? Can hear me or not, Hashini? Can hear now, Hashini? Yeah, I know your connection problem. Okay. Cannot hear me now. Okay, never mind, Hashini. You go out, then come in again. Okay. It's okay. Take your time. Don't panic. You go out, then come in again. Okay, Hashini. Okay, come. Justin, are you here? Justin Yip?
Yes, teacher.
Justin, can you explain how a submarine sink into the deep sea? How the submarine sink?
There's a ballast tanks in
Ballast tank. So what to do with the ballast tank?
The ballast tanks allow the water to. It's used to control the volume of water on the depth from the surface of sea.
Yes. Now
when the ballast tanks, if you want to let the submarine to sink, you need to open the ballast tanks and let those water flow in.
Let water come in.
The weight increases. The weight increases is bigger than the thrust, so it will sink.
Yes, correct. Okay. In order for this ballast tank to sink, submarine to sink, right? So you need to fill up the ballast tank with water So when the water heavy, right? The weight heavy, bigger than the upthrust force already, right? So it will sink, all right? And how to make this ballast this submarine float up into the seawater surface? How
Let
to
the
do?
ballast tank to be empty.
Empty it by remove the water remove the water, make it empty, so it become lighter, so it will go up Okay, thank you. All right, next one is Lo Yongxi, are you there? Lo Yongxi, around or not? Lo Yongxi disappeared already. Yutong, okay, Wu Yutong, come please. Yutong,
Yes, sir.
Yutong can you explain why the hydrogen filled balloons will go up? Why the hydrogen filled balloon will rises up?
Because the balloon expands when hot, and the air displays.
Hydrogen filled balloon, not hot air balloon, Yutong. The hydrogen balloon. Why hydrogen balloon will rises up? Same like the answer you give just now, Why the hydrogen filled balloon go up?
The air displays produce upthrust.
Yes, correct, very good. Because you pump the hydrogen gas inside, so it's very light, but balloon become bigger, so it will displace the air. So the weight of the air display produce upthrust force. So that's why upthrust force bigger than the weight, so it rises up. Okay, thank you, Yutong. Hashini, it's okay, don't worry. Hashini is okay. I know, I understand sometimes the line problem. Hashini is okay, don't worry. Okay, and last question I want to ask. Venom Teo, are you around? Venom Teo?
Not around. Yeah.
Not around. Very smart are you? Not around some more you answer. Okay, Venom, can you explain how hot air balloon rises up? How the hot air balloon can rise up? Venom?
Turn on the fire.
Now you on the fire. Why you on the fire?
Expand the balloon.
To make the balloon bigger, right? Why you, after you make the balloon bigger, what happened?
Rise up.
Rise up, you never explain the theory. Why the balloon expand, it will rise up, then why? You need to explain a little bit further, You look at the screen, when the hot air balloon expand already, so what happened?
Weight of air displays.
It will displace more air, right? When more air displays, mean the weight of the air display bigger, so the buoyant force become bigger lah. That's why it will rise up. Okay. All right. Thank you, Venom. Okay. Now one more to go. Hydrometer. This thing I never understand why in the SPM they ask many times on hydrometer. Become very important in the SPM. Surprisingly, I don't know why this hydrometer became that important in the SPM. Okay, hydrometer actually is instruments are used to measure the density of liquid. Measure density of liquid. Okay, simple things you see here. This is a long tube, right? So this is the bow. So you have a little bit of left shot to make this one bottom heavy, I told just now. You need to make the bottom heavier so that when it floats, it will stand upright. Okay. This hydrometer actually is like this, There are scale here. The scale 0, 5, 10, 15, and so on. When you put into a liquid, it sinks very deep. It sinks very deep. it means the density is very low. When you put in a liquid, like it sink a little bit only. It sink less means the liquid density is high. Understand? For example, like you put into this river water density low, right? So it will sink very deep. When it sink deep means that the water level reach here, so it unify. So very small density, right? Then after that, you put it into salt water. You put a lot of salt mixed inside the water, density high. Then you notice this thing will sink less. Sink less means the water, you see the level, the number become bigger. So remember, even in the SPM, they asked you before, why this hydrometer, the number 0 is on top one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that one. Why not start from the bottom? Why the smaller number must be on top? Why? Because smaller number on top here means the level sink is very deep inside. It sink a lot already. So the density should be small. So the smaller number should be on top. Okay. So how this thing work? Okay, let's go through one by one. Highlight. Hydrometer is an instrument used to measure the density of liquid. Okay, highlight. Measure density of liquid. It has a glass bowl. This is a glass bowl. Contains some lead shot. I got lead shot, make it heavy to make it float upright, because bottom heavy, it won't topple, it will always stand up. And long narrow net. This one must be long and narrow. Okay. With a skew mark on it cause the hydrometer more sensitive. Highlight. The tube must be small and very long. Okay. So this hydrometer will be more sensitive. Can detect very small density. The last airfield here, why this size must be very big, because you want to displace more water. Last airfield glass bowl used to displace more liquid, cause the upthrust to increase, hence the hydrometer can float longer, not sink too fast. When this size of the bulb big means it can displace more water. More water displaced means the buoyant force stronger, means this hydrometer will not sink so fast. When it sink very fast, you cannot measure so much thing. You measure 1, 2 type of liquid, then it sink deep already, so no use. It should be sink less, a little bit only. Okay, that's better, more sensitive Okay. This one is important. In the liquid of less density, less dense, the hydrometer more submerged. When you see the hydrometer submerged deeper, means the density of liquid is less. The hydrometer floats higher in the liquid of higher density. So remember, when this liquid density high, so it will float. It won't sink so much. Okay. So understand hydrometer. Okay, there are a few things I remember. Always came out in the SPM, they ask you to design a hydrometer which is more accurate, more sensitive, can measure bigger range of density. So how you design it? I repeat my question. It should be more sensitive. More sensitive. Okay. Answer, measurement more accurate, more sensitive. And then one more they ask is, can measure bigger range of density. So how you must do it? How you design the thing? 10 marks question in the SPM. Okay, first you must say, this tube must be long, narrow. Long and narrow means, long means your skew is bigger skew 0 to 1000 maybe, right? So bigger skew means you can measure bigger range of density. The range are from 0 to 1000 also you still can measure. So you must be longer tube. Okay? Narrow. Narrow mean more sensitive lah. The skew lah. The skew you mark here, the skew must be smaller skew. The smaller skew you mark here mean more sensitive. Okay. Right? You want the answer to be more accurate, so the skew must be smaller lah. Okay, huh? Okay, now answer question. Yeah, now you take your time, go and answer. Try first, okay? Later I ask you, you give me answer. Okay, try first. Try to answer the question. 1, 2, 3, 4, 5. Okay, not difficult the question. Okay. Okay, question 1. What answer? Figure shows a load hung from a spring balance slowly submerged in the water until immersed completely. Slowly until immersed completely, slowly. Okay. What will happen to the spring balance reading?
Yes, sir.
Yes, Kevin? Yes, correct. Decreases until reach a constant value. Yes, very good answer. It will decrease, and finally become constant. Okay, when fully submerged already, right, it will become constant. Okay, so answer donkey. Okay, question number 2. Which one of the following is true? See carefully now. Look at the density, look at the level of the object, sink, and then which the answer is correct. High density means the object wouldn't sink so much. If the density is low, it will sink very deep. So which one is also the best answer here? Which one is the best answer? Chao Yang bola. Chao Xian, Ong Chao Xian. Chao Xian, which one is the answer?
A.
Yes, correct. The answer A is the best answer. This one density the highest. When density high means you cannot sink. So it float very high. This one medium float. This one sink deeper. This one density very slow. It will sink a lot. Okay. Okay. Number 3. Which one is correct? Think carefully. Which comparison is correct about the density? Density of PQRS. Which one density is the lowest? Which one density is the highest? You see the level of the ball sink. The level of the ball sink, then you know the density already. So what answer here? This one is asking the density of the sphere, not the density of the water. The water, same one. They are asking which one density, the ball density is higher. Okay, so which one is the answer? Yao Siqi, which one is the answer?
A. A.
Yes, the answer A. This one sink very deep. Sink very deep mean it's very heavy lah. Density very high. The second one should be Q or R lah. We know this one, the density is the smallest lah. But between Q and R, so which one is the answer? Which one should come first? This one, no argue, this one density the highest lah. Then followed by Q or followed by R. This one should be the last one, no? So which one is the answer? Eh? 17 say A or Ken Leong, what about you? You say A or C?
Sure.
Huh?
Not sure.
Okay, I will say this one density, this one is the highest lah. This one the highest, number one. Number two, I say this one lah, because it sing a lot, you know. The level is sing lah. This one number two. This one number three. And this one is the last one lah, because sing a little bit only mean the density very, very small lah. Okay. But between 2 and 3 is hard to argue lah, huh? This one number one, the highest density. This one sing more than half already. This one sing less than half. I say this one number two lah. So I take the answer C lah, huh? Okay. P followed by R followed by Q and last one is the S lah. Okay. C. 17, can you accept the answer or not? Yao 17?
Yeah, can.
Can now, okay, yeah. Okay, number 4. Calculation. So what answer? Number 4. Metal block volume 0.002. Immersed in the water. Density of water 1000. What is the buoyant force? Direct lah. Direct calculation. Okay. Just direct calculation only lah. Huh? Rho Vg. Rho is 1000, volume, gravity. So you get 20 Newton. Okay. This one okay, huh? Number 5. Number 5, you need calculation like this. A lot of calculation here, no? Number 5. Okay, you see, understand it, huh? Object mass 2 kilo, density 8 times 10 power 3, immersed in the sea water. If the density of sea water given, what is the upthrust buoyant force? Okay, first you find volume. Density is mass over volume, so volume is mass divided by density lah. Mass is 2 kg, density 8 times 10 power 3. So you get volumes of the object in this one. We always know that the volume of the object is equal to the volumes of water displaced. Same one. Okay. Volume of the object, when it submerged into the water, the volume of water displaced is the same lah. Okay. So you can put here rho Vg. So you get 2.575 Newton. Rho density given, volumes of water displaced equal to the volume of the object lah, times gravity 10. So you get this answer. Okay, 2.6 Newton lah. So understand this question. Zhao Xian, understand or not?
Understand, sir.
Okay, come number 5. Object volume given, hung from a spring. The reading of the spring balance is 8. If the object immersed fully in the liquid density 600, determine the reading of the spring balance now. How you do it? 1 minute, okay, your try. Actual weight is 8. When you submerge fully into the liquid of density 600. So you must find the buoyant force lah. After you know the buoyant force, then you can find the apparent weight. The question asking about the apparent weight. Anyone got the answer? What is the apparent weight? Anyone got the answer? Simpun Keng can get the answer or not? Simpun Keng? Okay, someone give answer already. Hashini say the answer is 5. Let's check, Hashini. Yes, correct. Very good, Hashini. You are right, okay? 5 Newton. Thank you, Hashini. First, you find the buoyant force lah. Rho Vg. Rho 600. V density. Volume. Volume of water displaced always same as the volume of the object lah. When the object submerges into the water. So you get 3. 3 is a buoyant force. So to get the apparent weight, so you take actual weight 8 minus 3, so 5 Newton. Okay? Can I understand? Okay, number 7. Direct. This one, rho Vg. 20 Newton in the air, 15 Newton in the liquid. So straight away you know the buoyant force is 20 minus 15 is 5 lah. Buoyant force is 5. Rho volume, given volume, gravity. So you find the density, so it's 1000. Okay? So okay, Okay, number 8. Which are the following about the ship floating on the surface of the sea is true? Floating on the surface of the sea. This question a little bit tricky one. Be careful. The ship is floating. So which one is correct? Which answer is correct? Come on, please. Try your answer. Okay, one student give answer already. Ge Zizhen say the answer is B. Okay, one more student. Any more student give answer? Ge Zizhen say B. Any more answer? One more student give answer, please. Any more? Kian Leong, where is your answer, Kian Leong? Kian Leong, too low profile, you. Where is your answer, Kian Leong? Kevin? Kian Leong, wait, ask me to wait. Kevin, you got answer already, Kevin?
Yes, I haven't.
Oh, just went to toilet, Kian Leong. Kian Leong. Number 8, what answer, Kian Leong? Ship floating on the surface of the sea. Which one is correct? If you really understand the buoyant Archimedes principle, you should be able to answer. Taikalok says C. Taikalok. Okay lah. So the answer actually given by 指正啊，个指正 is correct. The answer is B. Yes, correct. First answer is correct. Okay. Actually, it's a weight of liquid displaced by the sphere equal. Sorry, I think I keep the wrong. The answer B, yes. Now it's here, sorry. B. Here, I see the wrong thing. The weight of the ship equal to the weight of seawater displaced. So answer is B. The weight of the ship must equal to the weight of the seawater displaced. This is Archimedes Principle, right? Okay. One last question. Number 9. Which one is the answer? Figure show a spear floating. The spear floating here. So which of the following is true? A, B, C, D. So which answer is correct? Okay, come on, please. Give answer, please. Student, give answer. Still no answer yet. Come on, come on, come on. Still waiting for your answer for number 9. This object floating, so which answer is correct? Kevin Lim, please give answer for number 9.
Wait, sir.
Kalai, number 9. Which one is your answer, Kalai? Justin said B.
B, sir.
Yes, correct. The answer is B. Yes, correct. The last one already. The answer is B. Weight of the liquid displaced by the sphere equal to the weight of the sphere line. So, correct the answer. Okay, one last question. Number 10. 2000. The buoyant force must equal to the weight of the thing. 200. The weight is 2000 Newton. So the upthrust is also 2000 because upthrust must equal to the weight because this thing floats stationary. When it floats stationary, means the upthrust equal to the weight So the weight 2000, so the upthrust is also 2000 Okay class, I stop here Okay. Okay, from fine. Okay, everyone. I hope you all understand tonight's lesson Any question to ask here? Lotus, Lim, Jia, Xuan, anything to ask or not? Any question from you? No question, no sirs, you say. Sao Kang, anything? You got anything to ask or not? Sao Kang? Nicole Tan? Nicole, anything to ask?
No.
No. Kylie, any more thing to ask?
No, sir.
Okay, no question. So I see you all next week again. Okay, bye-bye, class. Bye-bye, everyone.
Thank you, sir.
Okay, bye-bye,
Thank you,
everyone.
sir.
All right,
Thank
bye-bye.
you, sir.
Okay, bye-bye. Bye-bye.
Thank you, sir.
All right, bye-bye.
Thank you, sir.
Okay, bye-bye, bye-bye. Okay, bye-bye, everyone.